touch on polyprotic acid-base titration briefly. So recall, polyprotic means something that contains two or more protons. And the example we're going to use is carbonic acid, H2CO3. And we know that the series of proton reactions it can go through. So we have our carbonic acid. The conjugate base of that is bicarbonate, okay? And the conjugate base of bicarbonate is just carbonate. So if we were starting over here at 0, so we can imagine now we're starting with just carbonate. And as we add, see this volume of strong acid titrant. So if we add now strong acid, that goes to a complete reaction, and that makes our bicarbonate. And now we can keep adding strong acid to our carbonate until we get to that first equivalence point. And at that first equivalence point, I've completely used up all of my carbonate. And the only thing left I have is bicarbonate. And we recognize that first equivalence point will be basic because bicarbonate is a conjugate base. So it will go on to react with water to make more carbonic acid, but importantly, it will make hydroxide, which is why that first equivalence point is basic, okay? So now in this region right here, so I'll say between here and here, okay, we definitely have some buffering going on, right? But now in this region, we're looking at HCO3 minus our bicarbonate plus H plus. That's a full forward reaction to now make H2CO3 to make our full carbonic acid. And now when we hit our second equivalence point, we've completely consumed our bicarbonate. So now we only have carbonic acid left. And now this second equivalence point will actually be acidic because now my carbonic acid is a fairly okay acid, and it will go on to produce H plus, okay? So now these polyprotic acid-base titrations can get a little confusing. So the way that we think of these, the way that we would start them is way up here. Let's say if we were starting with the carbonate, right, it's completely unprotonated. So we're going to now see two of these equivalence points corresponding to the two proton reactions that have to go. If instead we had started with all carbonic acid, then we would see the exact same titration curve. It would just be a mirror image, okay? And we could expect something similar for our other polyprotic acids. But that's all that I really want to say about polyprotic acid-base titration. It can get a little complex, and it is a little beyond the scope of this course. But for you chemistry majors, for you that go on, you'll explore a lot more of this in some of the upper division classes. Okay, folks, I think that's it for our Part 1, Chapter 16.